In this video, we will be going over examples for evaluating inverse trig functions. So the first thing we need to know is the restrictions on all of the trig functions. We can see that sine, cosecant, and tangent go from negative pi over 2 to pi over 2. That puts them in quadrant 1 and 4. And cosine, secant, and cotangent go in quadrants 1 and 2, putting them between 0 and pi. However, there's little asterisks next to tangent and cotangent because they're actually going to end in parentheses because they are undefined. Tangent is undefined at pi over 2 and negative pi over 2, and cotangent is undefined at 0 and pi. So you will never actually get 0 pi out of cotangent inverse, and same goes with tangent for negative pi over 2 and pi over 2. So we have to think back to these restrictions when we're evaluating the function. For example, if I had something like sine inverse of negative 1/2, sine is, sine of 11 pi over 6 is negative 1/2, but so is sine of negative pi over 6. Right? So sine inverse of negative 1/2 is going to be negative pi over 6 because we have to keep it within this interval. Okay? So the other thing I wanted to cover real quick before we got into examples was composition of functions. Composition of functions, you may remember from previous classes, having f of g of x. That's f of g of x. That means you evaluate g of x and then plug whatever you get into f of x. Same thing here with trig functions. So sine of sine inverse of radical 2 over 2 means I evaluate sine inverse of radical 2 over 2, and then I plug that into sine. Just to note that this can also go the other way. So I could also have something like sine inverse of sine of 7 pi over 4. And then we can solve that as well. Okay. First example I'm going to look at is arc cotangent, and I wanted to do this one because I wanted to mention arc. Arc sine, arc cos, arc tan, arc cosecant, all of those things are the same thing as inverse sine, cosine, tangent, and all the others. So we're going to treat this the same. This is the same as cotangent inverse of negative radical 3 over 3. Now I'm working with cotangent, so that means I'm going to be in quadrants 1 and 2 from 0 to pi. The other thing I notice about this function is this function, it's clearly been rationalized. And so that means that I'm also can think of it as I'm looking for arc cotangent of negative 1 over radical 3, because radical 3 over 3 is not a value I get out of cotangent unless I rationalize. So I'm going to unrationalize it so it looks a little more similar. Now, we know that cotangent, a little side note, cotangent is cosine over sine. So this question here is basically asking me what angle has a cotangent of negative 1 over radical 3. So there are pretty much three options for cosine and sine: negative 1/2, negative radical 2 over 2, and radical 3 over 2. Those are kind of my options for cosine. Plus or minus 1/2, plus or minus radical 2 over 2, plus or minus radical 3 over 2. Well, I know I'm going to end up then with a fraction over a fraction. Maybe I'll write that down so we can have it. So cosine of theta and sine of theta, unless we're like in the 0, the 1 territory, are almost always going to be one of these. They're almost always going to be one of these three. I know that this is going to give me a fraction over a fraction. And when I have a fraction over a fraction, I keep, change, flip. And the denominators happen to always cancel, or a denominator and a numerator happens to always cancel when we do trig functions. So I know I want to be left with a negative 1 in the top and a radical 3 in the bottom. Or, either or could be negative. But if I'm negative, cotangent is negative here, and cotangent is positive here. So I know I'm looking in quadrant 2, which means that cosine is negative and sine is positive. And this is what I need to happen when I keep change flip. Well, that would leave me with this has to be a 2 and this has to be a 2 because 1, they have to cancel, and 2, these are my only options up here. Okay, these are my only options. This is a process that will get faster as you practice. This is something that you can normally do in your head. I'm only writing it out for the sake of this video. So that tells me I am looking for the angle. I'm asking myself the same question. What angle has a cosine of negative 1/2? And that same angle should have a sine of radical 3 over 2. So that means it's going to be shorter on the horizontal. The horizontal distance is going to be shorter, and the vertical distance is going to be longer. And that right there is 2 pi over 3. So that means that the arc cotangent of negative radical 3 over 3 is 2 pi over 3. This next problem is going to be one where they match. Now, when we did this problem previously, where they match, they kind of just canceled out. Which is why I wanted to do another one where they don't cancel out. So looking at this, I evaluate from the inside out, right? I'm always going to evaluate from the inside out. Okay, so I'm going to start, since it's a composition of functions, I am going to start with the sine of 7 pi over 4. I just want to find the sine of 7 pi over 4. Okay, this we hopefully have memorized, but in my head, I'm visualizing, okay, that's right here. That's my halfway distance, which is always my radical 2 over 2, but I'm in the 4th quadrant, so I'm going to go down forever, or I'm going down, so it's negative. So that's going to be negative radical 2 over 2. So then I'm going to have sine inverse of negative radical 2 over 2. Okay, and that is going to cause me to look in quadrants 1 and 4. And I can't just say that it's 7 pi over 4 because 7 pi over 4 is not a part of my domain. My range, right? So when I look for sine inverse, I'm going to be looking in quadrants 1 and 4. But that's from pi over 2 to negative pi over 2. Okay, so when I go here, that's not actually 7 pi over 4. I need to write it as negative pi over 4. Okay, so that is going to be my answer though. It's going to equal negative pi over 4. All right. This next one is very similar, but it just mixes cosine and sine. So we will again start from the inside out. When I look here, cosine of 5 pi over 6, that angle's right here. It's the longest distance. It's going to the left, so it's negative. So that is going to be negative radical 3 over 2. So next I have sine inverse of negative radical 3 over 2. But since I am looking at sine, I am going to be looking again in quadrants 1 and 4. So I'm looking from here to here. It's negative, so I'm going down. I'm going down the longest distance. That's going to be this measure. And so that one, it's kind of confusing because we started with a positive 5 pi over 6, and it was pi over 6, but that's actually going to be negative pi over 3 because now we're looking at sine. Okay, so it's also 5 pi over 3, but again, we need to think of it in terms of the range of sine, which is from positive is on the top, positive pi over 2 to negative pi over 2. So that is going to be negative pi over 3. Negative pi over 3. All right, let's do 2 more for good measure. This one's got cotangent on the outside and secant inverse of 2 on the inside. So I'm going to start from the inside. Looking here, that means I'm asking myself what angle, this is essentially saying what angle has a secant of 2. I'm not super, like, the secant, cosecant are not something I have memorized or I'm as familiar with. So I'm going to switch it to cosine, right? That's the same thing as asking what has a cosine of 1/2. Well, since I am doing cosine, that means that I am going to be in quadrants 1 and 2. So I'm from 0 to pi, and a cosine of 1/2 means I'm going to be halfway. It's going to be here, and that is going to be 2 pi over 3. That's going to be 2 pi over 3. So now we have cotangent of 2 pi over 3, which is the same as cosine of 2 pi over 3 over sine of 2 pi over 3. And lucky for me, I already have this angle sketched. So I know I'm going over negative 1/2 up radical 3 over 2. So that's going to be negative 1/2 over positive radical 3 over 2. And here's that keep, change, flip I was talking about that I worked backwards from on that earlier problem with 2 pi over 3. And I'm going to get negative 1 over radical 3. Last one, super similar, but now we're looking at cosecant. I had to go back because I thought maybe it was the same thing. Again, working from my inside out. I'm going to start here. I'm looking for where the cosecant of some angle is 2. Well, that's the same as asking where sine of theta is 1/2. Well, since I'm working with sine, that means I'm looking in quadrants 1 and 2, but because it's positive, I'm looking in quadrant 1. 1/2 is going to be halfway up, and that is going to be pi over 6. So cosecant inverse of 2 is going to be pi over 6. Okay, now what that leaves me with is cosine of pi over 6. And again, I already have the angle drawn. My cosine is going to be radical 3 over 2. And there we have it. There are some examples of evaluating inverse trig functions, normal trig functions, composition of functions, and giving exact answers.